All right. Y'all yell at me if I don't see somebody come in. Facts about correlation. It's not going to take up this much room, I promise. Correlation makes no distinction between explanatory and response. Okay, so correlation will not help you determine which one is the explanatory and which one is the response variable. R does not change. Thank you. When we change the units, of measure for X or Y or both. And then number 3 is super important. The correlation R itself has no units. So if you're measuring in inches for your whatever, correlation is not like 0.9 inches, okay? It has no units. Describing the relationship between two variables is more complex than describing the distribution. Here are some cautions to keep in mind when you use correlation. This very first one you'll hear a lot. Correlation does not imply causation. All right, so let me give you an example. If we were measuring heights of, like, let me see. I don't want to do that. Here we go. Average salary, because I think we've done this before. Average salary or average income compared to foot size. Are those two related? Not at all. No, because if you could have little feet.
Maybe it's a big foot.
Well, you could put in athletes in there too, but there are more than just athletes that have feet that big. So you can't, they balance each other out, if that makes sense. So they are honestly not related. So if we look at it that way, you're going to see if you plot them that there may be some kind, it looks like a pattern or whatever, but just because they have a correlation that's strong doesn't mean that they have causation. That's what it's saying. So their correlation might be strong. You're right. So an athlete that makes more money is going to probably, if it's a male, is going to have a bigger foot. Y'all agree with that? They're usually bigger and stronger. Got it? Everybody understand that? But that doesn't mean every big-footed person makes more money, because there are big-footed people who have no job. You understand what I'm saying? Those two are not related. So the correlation does not mean causation. All right. Correlation requires both variables to be quantitative. We could do your age and the amount of money you make. Typically, the older you are, the more money you should make, right? Not always the case. We can't imply that.
Okay, well, yesterday you said about the type of treatment and how many years they lived after having that treatment. How would the type of
How the what?
the type of treatment they received before it instead of categorical quantitative?
It is probably the amount of treatment. The amount.
Radiation versus removal.
Yeah, it builds on itself. So don't, just like yesterday when you guys were talking about, do I say strong? Do I say moderate? Now you know exactly when you say it. So it's just like you were asking me about the symbols when you emailed me about those symbols. Like right now they're using the population standard deviation, but we really should be using the sample. But they eventually go into it and say, okay, quit using this and start using this because we know it's a sample that we took.
Wait, so we were supposed to
No, you're fine using whichever one you want to right now. Okay. Correlation makes no distinction. I'm not on the right page. Correlation does not describe curved relationships. Between variables, no matter how strong the relationship.
Say variable.
Between. The value of R. Sorry, Al. Close to 1 or -1. Does not guarantee a linear relationship between two variables. And we'll get into all of this. Don't stress about it right now, but we'll get into all of it, okay? It's just kind of introducing you into it before we actually go into it in 3-2. Like X bar and the standard deviation, R is not resistant. R is strongly affected by outlying observations. Just like we were talking about Mississippi earlier, taking that 1 point out really does change and affect the correlation. And then the last one, correlation is not a complete summary of two variable data. Okay, so you can't just say there's a strong positive and move on. There's more that you have to do. All right, Zoomers, when you're done, you can get out of here and go do your quiz. Monday, when you're in class, we'll go over your free response on your test. If you are all remote, please see me to go over that free response. If you'd like to do that, you just have to set up a time with me.